Okay, I'd like to go over the vocabulary problems. This is page 4 of test 2.1. Our first vocabulary word is discrete. Discrete is the name of a relationship, or how you would describe a relationship, that creates data that can only take on certain values. There's only specific values that will work in these relationships. For example, if we were counting, like getting a penny every day, we don't have partial days, we just have whole days. Or if we were counting the number of cars, it would be whole cars, not partial cars. Okay, so we'd have things like days, months, or counts that have to be whole numbers. If we're graphing a discrete relationship, basically when we graph that, when we plot the numbers, it's going to be just the dots is all we're going to plot. So that would be a linear version of it. If we had an exponential graph, it might have a curve to it. Those are discrete relationships, only certain values, no line connecting the points. On the other hand, a continuous relationship creates data that can take on any value. Well, any value within reason. So there are some continuous relations that can use any numbers from negative infinity to positive infinity. But many times it's a smaller set of numbers. For example, if you are measuring the length, say, of a snake. So a snake could be a few inches long all the way up to several feet long, and it can take on any measurement in between the smallest and largest size of a snake. If you were to graph a continuous relation, then usually what we would do is we would start with some values that we might generate from our equations, but then what we would do is we would connect those values. What this means is for any value of x, we can calculate a y value. Okay, so you're allowed to have fractions or decimals for your x values. Instead of, we can't have half of a car or half of a day, but we will, you can have half of an inch or half of a foot for, say, like a snake. Okay, so we have a smooth line. In the event of a curved function, again, you would plot the points, or some of the points, and then you connect those, and that gives you your continuous relation. Sometimes on continuous graphs, you'll get, we'll put arrows at the end, but it's okay. You don't have to have arrows. A lot of times we'll just assume that the continuous relation would have those arrows there. Okay, a couple other things about graphs and relations. They can be increasing or decreasing. So a relationship is increasing when the y values increase as the x values increase. I think the easiest way to see this is just to look at a graph. So the x values get bigger going to the right. The y values get bigger as they go up. So if we have values, say, that do that, if you think about it, the y values from point to point keep getting bigger. They move up the page. At the same time, the x values get bigger. They move across the page. This is an increasing relation, or increasing function. On the other hand, a decreasing function is a relationship that's decreasing when the y values decrease or get smaller as the x values increase. If we look at a graph of this, so here's what we're saying. The x values increase going to the right. On the graph, the y values, or on the axis, the y values increase as you go up. That's the normal way, to write that. Like you might have 1, 5, 10, this way. But the actual values in your graph get smaller as x gets bigger. That's a decreasing function. Okay? An example of this might be if you have, say if you have $500 in the bank and you spend $25 a month on your cell phone. okay, that takes away money, so you have less money as the months progress. Okay, the next word that we have is domain. The domain of a relationship is the set of valid numbers for the x values. In a way, when we think about the difference between discrete and continuous, it involves domain issues, because the domain on discrete would be just these particular x values that are used to build your graph. The domain of a continuous function are all the values that fall between a given range. So a domain of a relationship is a set of the valid numbers for that, and the domain is not always all real numbers. The domain could be a set of valid numbers. So let's say if we have the height of water in a pool or in a swimming pool, the valid numbers would be, say, from 0 inches to, let's say it's a 4-foot pool, 48 inches. So you can't have more than 48 inches because then it would overflow. So the domain would be 0 to 48. It could take on any value between 0 and 48, but it can't be smaller than 0 and it can't be bigger than 48. Sometimes the domain is written in interval notation, like 0 to 48. It could also be written in inequality notation, and whatever variable is there, we'll just use x for now, but it could be any variable, 0 to 48, and actually it could be equal those values. So the domain could be written that way. Sometimes just the letter D is used to denote domain. Okay, calculator entries. Basically, I showed you this in class. If you wanted to create a graph, you use your Y1 screen, Y equals screen. There's a Y equals button on your calculator. So the Y equals button is on the top left of your calculator. And if you go to that, you can see you have a place to enter a lot of different functions. So you could put in any function you want. If let's say we wanted to put in an exponential function, we could write, let's say the 0th term is 10, and the common ratio is 2. Basically, you would plug in this function into your calculator. Turn that off. So we'd have 10 times 2 raised to the x power. And then you could graph that. I'm going to do zoom 6 for a standard view. Okay, and you can see what that graph looks like there. If you had a linear arithmetic function, you could actually put it in the second graph. You could leave that one in there. And for graph 2, I'm going to say my linear function is, say, 3n plus 5. Let's say that that's what it was. Now, your calculator doesn't have n per se. It doesn't really care what variable you use. I'm just going to type in 3 and then x. If you look, it says x, t, theta, or n. It's going to display in x, though. 3x plus 5. And you can graph that. Now, I left that other graph on, so it's going to show both of these at the same time. There's linear. Now, your calculator doesn't really understand the difference between continuous and discrete, so you need to keep that in mind. It's going to graph a continuous function. If it needs to be a discrete graph, then you need to take care of that kind of manually when you're creating the graph on your page. If you wanted to see certain values that these take on, you can go look at table. I'm going to hit second table, or the graph button. And basically, I have a lot of stuff in here, but you could see for different values of x. I'm going to change my table real quick. Table set tells you your start value, so I'm going to start at 0. Table start at 0. Table change is 1. So I'm going to look at that real quick. And you can see for these different x values, and these could be your discrete values, here's the y values for graph number 1, that was our exponential. Here's the y values for graph number 2, that was our arithmetic. All right, there you go.